Good morning, everyone. It's Friday, so close to the weekend. So today we are going to start Chapter 17 and go over Section 17.1. Below are going to be your vocab words that I had you already put on note cards, and you should have sent those to me yesterday. If you did not send them to me yesterday, make sure that you send them today. So today we are going to start going over mechanical waves. Let's talk about what a mechanical wave is. So a mechanical wave is a disturbance of matter that carries energy from one place to another. Recall that energy is the ability to do work. So we have energy in these mechanical waves moving from one place to another. Think about a wave pool, or think about you being in the ocean. What happens to your body when you are moving through that wave, right? Isn't that wave transporting your body somewhere? So that is the energy of the wave doing work on you. So you could either go up and down. Sometimes it pulls you a little bit to the left or right because of the current, but it is doing work on you. So what is this medium? So a medium is a material through which a wave travels. So it could be a solid, it could be a liquid, or it could be a gas. Well, what is the medium in a wave pool? What is the wave traveling through? Water. So it's going to be water, the medium of a wave pool. And that is going to be an example of a liquid. A solid could be, think about an earthquake. It's sending waves through the Earth's surface. And then a gas, well, how you're listening to me right now, that is an example of a sound wave. So a mechanical wave is created when a source of energy causes vibration to travel through a medium. So you're hearing this because of the vibration of my body sending a distribute through the air, and that is how you're hearing me. Think about an earthquake. There's a rumble, and then it sends vibrations through the earth. So there's going to be three types of mechanical waves that we talk about. There's going to be transverse, longitudinal, and surface. Those are the three that we will be describing today. I will describe them to you, and then I will show you them on a slinky. Well, I'll show two of them on a slinky because it's easier to see when I'm working with that. First one we are going to talk about is transverse waves. So these waves are going to have a crest and a trough. A crest is going to be the highest point of the wave, and then the trough is going to be the bottom part of the wave, so the lowest point of the wave. The direction of these waves are going to move from left to right. That probably looks backwards for you guys, but it's going to move from left to right. And then the particle motion is going to move up and down. So as the wave is moving left to right, your particles are going to be moving perpendicular to that, and they're going to be moving up and down. And they use this great example out of the book. How many of you have been watching a movie and you're eating popcorn and you're snuggled under a blanket and you see all these particles on your blanket and you're like, oh, absolutely not. I don't want that there. So you try to get these particles off. Yeah, some of you might go like this and get them off. Easiest way to get them off is move your blanket up and down, right? So here's a blanket. I'm moving that wave up and down, right? So it's gonna go left to right. My wave's traveling left to right, right? But my particles are gonna move up and down. So that is how my popcorn or whatever snack you're eating is going to get off that blanket. So that's an example of a transverse wave. Longitudinal wave is a wave in which the vibration of the medium is parallel to the direction the wave travels. So for this example, your waves are going to be traveling from left to right, and your particles are still going to be moving left to right. So this means that they can go, so they can go both back and forth with this one, but their particles are going to be moving the same with them, from left to right or right to left. So, for example, this one, sorry, I had an itch in my eye. The difference between longitudinal and transverse is that transverse, they're moving left to right, their particles are moving up and down. So the particles are moving perpendicular to the motion of the wave. Longitudinal, they're going to be moving parallel with each other. So in a longitudinal wave, you're going to have compression and refraction along the way. When they are compressed, they are going to be very close together, and you can see that in the beginning of the first picture. And then they are going to spread apart, and that's going to be refraction, and then they kind of compress back together. The particles are going to be moving along the way with them. So an example of this would be earthquakes. They compress and refract, and they move across the earth. Surface waves is the last one that we are going to discuss. It's a wave that travels along a surface separating two media. So what I want you to do is look at your book, because they give you a perfect example for this picture. And you're going to turn to page 503. And it says, I'm going to read you actually kind of the paragraph to describe, so it's easier for you to see the picture right now and listen to me. So the floating fish or bobber helps to visualize the motion of the medium as the wave carries energy from left to right. So surface waves are going to be a combination between transverse waves and longitudinal waves. So the floating fish bobber helps to visualize the motion of the medium as the wave carries energy from left to right. When the crest passes the bobber moves up. So when we have that point of the crest, the highest point of the wave, the bobber is going to move up. When the trough passes, the bobber is going to move down. So this is the up and down motion. So if you look at a bobber, or if you're fishing, you can see it moving up and down. So at the crest, it's going to move up. Then at the trough, it's going to move down. But remember, I said surface waves are going to be a combination of transverse and longitudinal. Well, we have the transverse part where it is moving up and down. Let's talk about how it's going to be moving sideways. So, but the bobber also is pushed back and forth by the surface waves. This back and forth motion, like the motion of the longitudinal, is parallel to the direction in which the wave travels. When these two motions combined in deep water, the bobber is going to be in a circular motion. So it's going to go up and down, move from left to right or right to left. It's going to do a circular motion. So if you watch a bobber for 10 minutes, it would not move closer to shore. It's not going to be moving because it's in that circular motion. So we're going to be going up, down, and sideways. So your bobber is not going to be moving. And that's because it's in that circular motion. So we have transverse, longitudinal, and surface waves. So let me pause this and go get my slinky, and I will be able to show you exactly kind of what they look like. All right, guys, so I have my slinky here. Let me go back to this slide. So transverse waves. Transverse waves are going to have a crest and a trough, and my particles are going to be moving up and down, but my wave is going to go left to right. So there's my wave. My particles are going to be moving up and down. If I pause this, your crest is going to be at the top, your trough is going to be at the bottom. So watch, my wave is moving through this slinky left and right, but the particles are going to go up and down. Then we have our longitudinal waves, and that example was that the waves are going to be moving parallel to their particles. Sorry, Walter's getting in the way. Look at that. So you can see that the particles are moving in the same direction that the wave is. You can see the compression and then the refraction. And that is going to be an example of our earthquake waves. Remember, compression, they come close together. Refraction, they're going to go farther apart. And you can see where they compress because it becomes denser and darker. All right, guys, that's it for today. Have a great day.